Hello everyone. So today we will be discussing about velocity. Last class we had to discuss about speed and velocity also, but we only discussed about speed. Don't worry, today's class we will be discussing about velocity, what it is and all. Okay? Okay, so my name is Shishan Reddy. I'm a graduate from IIT Dhanbad. So let's start the class. Right, so let's first very quickly revise what we have learned about speed. So what did we learn? We learned that speed is equal to what? Speed is equal to distance by time. Very simple. Speed is equal to distance by time. A very simple formula. Yes. And then we also got the formula for distance. What is distance equal to? Distance is equal to speed into time. And we got the formula for time also. What is time equal to? Time is equal to distance by speed. Yes, time is equal to distance by speed. So we got these three formulae. Then we also discussed about average speed. What is average speed, everyone? Average speed is equal to total distance upon total time. Total distance upon total time. Did we discuss anything else? Yes, we did discuss some other points. For example, the unit conversion 1 kilometer per hour is equal to 5 by 18 meter per second. Important. And while solving problems, you have to be careful about the units. The units also should cancel out. Right? We discussed about all these points. And one more important point that we discussed was about scalar and vector. So what do scalar quantity mean? What do scalar quantities mean? These are the quantities which have only magnitude. That's it. They have only magnitude, no direction. Example, mass. Speed, in fact, is also a scalar quantity. Then we also discussed about vector quantities. What are vector quantities? These are the quantities which have both magnitude and direction. These are the quantities which have both magnitude and direction. Is that clear? So scalar quantities and vector quantities. Understood? Okay, simple enough. Now let's go into velocity. Now speed was distance by time. But along with distance, we also learned about something called as displacement. Yes or no? Do you know what velocity is going to be? It's simple. Velocity is going to be displacement per time or displacement by time. You are dividing displacement with time and then you get velocity. Now the question is, does displacement have direction? Yes. Why is that? Displacement is change in position. That means it is final position minus initial position. That's it. Displacement does not depend on the path. It only depends on the final and the initial positions. That's it. So displacement is also change in position. You can say change in position by time. Now whenever you have this type of formula, the definition will be something like this. It is displacement. Time is in the denominator. You are dividing by time. So it becomes per. Per will mean division. So per unit time. Clear? Yes? Okay. Or else you can say displacement is change in position. So you can say it has rate of change of position or rate of change in position. What does this rate mean? Rate will mean division with respect to time. How fast the position is changing. How fast the position is changing. That is rate. Okay. So if there is, let's say, time taken is less, it is more fast. That's what it is. So velocity is also defined as rate of change in position. Now comes the interesting point. If I ask you about displacement, is displacement a vector quantity? Everyone, is displacement a vector quantity? Yes or no? The answer is yes. Displacement is a vector quantity. Its direction is from initial position to final position. Yes, right. So because displacement has direction, time is a scalar, no direction. Velocity also has direction. That means velocity will be a vector quantity. So velocity also has direction, and the direction of velocity is same as direction of displacement, which is from the initial position to the final position. From the initial position to the final position, hence velocity is a vector quantity. I'll go into its units, don't worry. So let's say this is the initial position. And somewhere here, let's say you have the final position. Initial and final. Okay. So when you talk about velocity, or first of all, let's talk about displacement. What is displacement? The length of the straight line joining the initial and the final points. Or else if I need the direction of displacement, it is from initial to final. Like look at this. The straight line and the arrow. So in this direction, there will be displacement. So if displacement is in this direction, the velocity will also be in the same direction. That is, from the initial position to the final position. From the initial position to the final position. That is the direction of velocity as well as displacement, both of them. And again, if we come back to the formula, velocity is equal to displacement by time. Velocity is equal to displacement by time. What are the units of displacement? For displacement, it is meter. For time, it is second. So it is going to be what? Meter per second. It's going to be meter per second. So the SI unit of velocity is meter per second. Simple. That's it. Clear? Okay. So that's velocity. Ultimately, velocity is what? Displacement by time. So let's go into a few questions, then or few examples per se, where we'll understand things easily. So here, in the given case, calculate the velocity. Now for velocity for what? O to A and from A to B. Look at the diagram. Here it is the initial point. It starts from O, goes to A. From A to B. Then from B, it again comes back to A. So O to A to B, and then B to A. So here we will first find out the displacement for OA. Because why? We have to find out velocity for OA. Velocity is displacement by time. So to find out velocity, you need displacement. And time, obviously. Okay, so let's first find out displacement. What will you do for displacement? How do you find out displacement? Always remember, for displacement, look for OA, right? Look for initial position and the final position. We are talking only about O to A. So O to A, O is initial, A is final. So then you can go with final minus initial. What is final position? 35. What is initial? 0. So it is 35 minus 0. It's going to be 35 kilometers. Or you can say length of the straight line joining the initial and the final points. O to A, the length is how much? Length will be from 0 to 35 kilometers. And we have the time. What is time given as? 35 hours. So what will the velocity be in this case? Or else I'll write that down here. Velocity is equal to displacement by time. Velocity is equal to displacement by time. Displacement is 35 kilometers. Time is 35 hours. So does anything happen there? Does anything get cancelled? Yes, 35 get cancelled. 35 into 1 is 35. So what will remain here? What will remain is velocity is equal to 1 kilometer per hour for this particular case. O to A, the velocity is how much? 1 kilometer per hour. Clear? What about direction? Direction is towards right in this case. So velocity is 1 kilometer per hour towards right. The direction, initial to final, right. So generally we say right is positive. So here we are getting everything positive. Okay, that's for OA. Now let's go into the case of B to A. Look at this. We are going from, it's given as A to B. Okay, we'll do for A to B. Okay, so A to B. Now you do it, everyone. I'll just give you some time, 30 seconds of time. Should be enough. So please solve it. Find out velocity in this case. From A to B. To find out for what? A to B. So 3, 2, 1, and the time is up. Now how do we do this? As always, here for velocity you have to find out displacement. Look at the steps. Displacement, right? And for displacement you have to find out the initial and the final positions. So A is the initial position, A to B. B is the final position, A to B. Right, so here final position, you can say displacement, formula, final minus initial position. Here final position is 60, initial position is 35, 60 minus 35, 25 kilometers. And then time is given as 50 hours. If I go for velocity, what is velocity? Velocity is equal to displacement by time. Velocity is equal to displacement by time. Yes, what is displacement? 25 kilometers. What is time? Time is 50 hours. So how much is that going to be? It's going to be, you can divide that. Everyone, you can divide it. 25 into 1, 25. 25 into 2, 50. Right, 1 by 2. So it's going to be how much? Half kilometer per hour. Half kilometer per hour. Now it is also positive because see, initial to final. It's going towards right. Yes or no? Instead of position, I should have written final. So initial to final position, as you can clearly see, it is going from A to B towards right, and we know right is positive. So this is fine. Okay. So we solve the question is done. Now what we'll do is we'll go for a special case where we go from B to A. We go from B to A, so let me solve that particular case. Now when you say B to A, look at that, here it becomes interesting. So this is the initial point, yes or no? Initial position. And A here is the final position. Initial to final. Now look at the direction. Direction is what? Direction is towards left. Direction is towards left. So here, B to A, we say that displacement is equal to, what is displacement? The length of the line joining the initial and final positions from here to here is 60 minus 35. So you can say 60 minus 35. That's going to be how much? 25 kilometers. But interestingly, it is towards left. What does left mean? It will be negative. Minus 25 kilometers. One method, or else if you need using the formula, which is final minus initial position, you can actually do that also. Final position minus initial position. Final minus initial position. What is the final position? See, initial to final. Final is what? 35 kilometers. What is the initial? 60. So 35 minus 60. This is interesting. 35 minus 60. 60 is more, greater. So the number will be what? Ultimately you will get negative. So you normally subtract 60 and 35. You will get that as 25. But because 60 is more, you say it is minus 25 kilometers. And what does minus mean, everyone? Minus will mean that the direction is towards left. And obviously here, look at this. B to A. What is the direction here? Look at the straight line above. B to A, it is towards left. And towards left, as we know, is positive. sorry, towards left is negative. So towards left here is negative. Okay. And what about time here, everyone? Time is given as 50 hours. I'll write that down. Time is 50 hours. So if I go for velocity now, velocity is equal to displacement by time. What did we get displacement as? Minus 25 kilometers. Do not forget the minus sign. Now what is the time, everyone? Time is 50 hours. So what is that going to be? If you divide with 25, 25 ones are, 25 twos are, right? So minus is there, minus is still there. So it will be minus 1 by 2, minus 1 by 2 kilometer per hour. Again see that you get negative because it means towards left. Velocity, here it is towards left. What is the direction of velocity? Initial to final. Initial to final, left. Yes or no? Right. So that's what we are talking about. Clear? So that's how we find the velocity. The most important step will be to find out displacement. You can use final position minus initial position. If it is positive, that is towards right, you will get positive. If it is towards left, you will get negative. Then use the formula, you will get the answer. So that's how we find out what? We find out velocity. So coming back, here what did we get the velocities as? For this case, we got it as 1 kilometer per hour. Here A to B, we got it as half kilometer per hour. And for B to A, we got minus half kilometer per hour. Now the question is, if I ask for the complete motion from O to A to B and B to A, what is the velocity? Again repeat, for the complete motion O to A to B and B to A, what is the velocity? Will you tell that as 1 kilometer per hour, half kilometer per hour, or minus half kilometer per hour? That's the question. Right? So what is that going to be? That's what we have to find out. We'll try finding it out. Okay. So if we had the same example, I mean if the last class also discussed this. For speed also, when speed changes, what do? We define average speed. So here also we define something called as average velocity, which is nothing but total displacement by total time. If you remember, average speed is total distance by total time. Here average velocity will be total displacement by total time. That's it. Clear? Okay, now let's go into a simple question. So in the given case, calculate the velocity for the complete motion. Now when I am saying the complete motion, then which velocity you have to take? You have to take average velocity. Yes or no? So I'll give you 1 minute of time. Calculate the average velocity. Do that, everyone. Please do it. So the clue is to find out total displacement and then find out total time and divide them, you'll get the answer. Find out total displacement, find out total time, and then you'll get the answer. Clear? So 10 seconds more. So time is up. So here we have to find out average velocity. We'll do it. So our target is what? Finding the total displacement. Now how do you find the total displacement? Very simple. For the complete motion, this is the initial position. And for the complete motion, what is the final position? A. Yes or no? So that's what we need. Always remember, total displacement or normal displacement, doesn't matter. To find out displacement, what do we need? Initial and final positions. That's it. Now once you have these two, you can get them easily. So let's do that. So we got the initial position as O. Forget about everything else. Initial position O. Final position A. So you need displacement. So what is displacement here? You can directly get the length OA, length of straight line joining initial and final positions, length of OA, O0 to 35, or else you can use the formula final position minus initial position. I'll use that formula, final minus initial positions. So what is the final position, everyone? Final position is 35. What is the initial position? Initial position is 0. So 35 minus 0, that's going to be 35 kilometers. Simple. Right? And we got that as positive. See here, from O to A, right? You have to forget about everything. Here you have to only look at this. Here there is O, there is A here. So the displacement is towards right. That's what you have to focus on. Forget about the path. Forget about everything else. Initial position, final position, displacement is final minus initial, 35 minus 0, 35 kilometers. That's it. Done. You'll get the answer. Okay. Now once you get displacement, you got displacement. The next challenge will be to find out total time. We have to find out average velocity. So total time will be what? 35 hours plus 50. Plus 50, right? 35 plus 50 plus 50. 50 plus 50, how much? 100. 100 plus 35. 100 plus 35, you should know that now. 100 plus 35. It is how much? 135 hours. Yes or no? So you have, we got the total time as how much? 135 hours. Now once we get this, we got total displacement, we got total time, then we need average velocity. What will average velocity be? Average velocity is equal to total displacement by total time. Total displacement by total time. Okay, what did we get total displacement? 35 kilometers. What about total time? 135 hours. Now can we divide that? Can we simplify this? Yes. 5 into 7, 35. 5 into 27, 125. Let me show that to you. 27 into 5, look at this. 7 5s are 35, 3 carry. 5 to the 10, then 135. Right, 27 into 5 is 135. So if you cancel them out, you get 7 and 27. You cannot cancel them more. So the correct answer here is going to be 7 upon 27 kilometer per hour. That's the average velocity. Understood? So that's how we find out average velocity. And even average velocity can be negative or positive. Here it was from O to A towards right, so we get it positive. But if the direction is towards left, you will get it as negative. Understood? Yes? So I think I will summarize whatever we have learned. We learned about velocity, displacement by time. Velocity is equal to what? Displacement by time, and velocity is a vector quantity. What is the direction of velocity? From initial position to final position. From initial position to final position. And when I say, let's say positive plus V plus and then VE. It means the short form of positive. So positive velocity, what is that going to be? Positive velocity will imply direction is towards right. Will imply towards right. And negative velocity minus VE, negative velocity will imply towards left. Same as displacement, same for every vector as of now. These are the points that we have learned. And obviously we have learned that average velocity is equal to total displacement by total time. So we got both the cases. Okay, good. So let's go into another few questions. A simple question for you, can velocity be negative? We discussed that already. So I'll give you 30 seconds of time. I'll give you 30 seconds of time. So please solve this, everyone. Can velocity be negative? Yes or no? Very simple question. We have been discussing about it. In the problems we discussed about it in one of the numericals. And just now I summarized it for you. So can velocity be negative? The answer is what? By the way, time is up and the answer is yes, it can be negative because negative velocities will imply what? Negative velocity will imply direction is towards left. So positive and negative only show the direction, so they will take care of it. Clear? Okay. I'll go into another question. Another interesting one, by the way. When a body is traveling along a straight line, or you can say on a straight line, what is the number of possible directions it can take? You have options. So I'm not giving you any clue, you do it. Anyone try solving it? When a body is traveling along a straight line, what is the number of possible directions it can take? How many possible directions it can take? That is the question. Everyone, 15 seconds more. So 3, 2, and 1. The time is up. There is no bell, I know, but the time is up. So how many possible directions? And the answer is 2, B. Why? So think of it. Let's say you have a road. Let's say this is a straight road. Now on a straight road, if there is a vehicle, let's say you can take a car. Now where can it go? I'm saying only a straight road, nothing else. It can go towards right or it can go towards left. It can go forward or backward. Only two directions. Yes or no? That's why only two directions are possible. Normally towards right is positive, towards left is negative. Understood? Yes? That's what we are talking about. Okay. Understood? Now let's continue. Now we'll go into this. How to find displacement from velocity. It's like finding distance from speed. So what is the formula for distance from speed? We know that distance is equal to speed into time. Similarly, displacement will be equal to, in place of distance you have displacement, in place of velocity you have speed, time to time, time is time. So that's it. Similar formula, the only thing is when we need displacement we use velocity, when we need distance we use speed. That's it. Okay. Let's go into a simple problem then. Find the displacement of a body traveling with a velocity 30 meter per second for a time of 1 minute. Interesting question. There's a small trick there. So do it. Solve it, everyone. So you have to find out the displacement. Velocity is given, time is given. Very simple formula. So 5 seconds more. 3, 2, 1, and the time is up. Okay, and the correct answer is option C. Now why is it option C and not anything else? I'll explain. So here, what is given? Given information. Velocity is given as 30 meter per second. The time is given as 1 minute. Now look at this very carefully. Velocity, in velocity, the unit of time is seconds. In the unit of velocity, the unit of time is second, but here we are taking time in minutes. And seconds and minutes are not the same, so you have to convert them. So what we can do is we can convert minutes into seconds, because 1 minute is 60 seconds. We know the result directly. So time is 60 seconds and the velocity is 30 meter per second. So if I need displacement, it is equal to velocity into time. Now velocity is how much? 30 meter per second. Time you have to take it as how much? 60 seconds. Don't take it as 1 minute. Take it as 60 seconds, because here you can clearly see second and second. They are divided, so they will get cancelled. So here it is 30 into 60. 3 into 6. I think my mistake. It should be 1800 meters. Wrong option, right? Wrong option. So the answer should be 1800. My mistake. 1800. Clear? So that's it. There you have the answer. Understood? So the displacement is 1800 meters. Not any of them. Option C. 1800 meters. Clear? Okay. Now next. Finding time from velocity. Again, this is also similar. We know that for when you have speed and distance, time is equal to distance by speed. So here also, in place of distance, you'll have displacement, and in place of speed, you'll have velocity. So what is time equal to? Time will be equal to displacement upon velocity. That's it. Okay, let's go into a simple problem then. Find the time taken by an object to be displaced by 500 meters. If the velocity is 25 meter per second, you have 4 options. Displacement is given, velocity is given, so please solve it. Very simple. Write down the given information, then use the formula and you'll get the answer. Solve it, everyone. I'm giving you some time, so solve it. Displacement is given, velocity is given, so find it out. Yeah, let me solve it now. So here displacement is given as how much? 500 meters. And the velocity is given as how much? 25 meter per second. That's it. So time is equal to displacement by velocity. And what is that going to be? Displacement is 500 meters. Velocity is 25 meter per second. That's it. Now you can do the calculation, yes or no. Now look at this. What is 25 into 20? I'll do it here. 25 into 20. What is that going to be? You can do the calculation. 25 into 2 is 50. So 25 into 20 is going to be how much? 500. Yes or no? So when I say velocity is equal to 500 by 25, what is that going to be? 25 into 20 is equal to 500. So meter also cancels out, as you can clearly see. Second will remain. So it is going to be how much? It is going to be 20 seconds. That's it. It is going to be 20 seconds. Option A. Clear? So there you have it. Time taken by an object to be displaced by 500 meters is how much? 20 seconds. So we got the formulas for velocity, average velocity, displacement as well as time. Okay? Simple, right? Very simple. Okay, now let's continue. So another interesting question for us. Now here we have for speed and for velocity, both of them. So here look at this. An insect moves along a circular path of radius 10 centimeter. Circular path of radius 10 centimeter with a constant speed. It takes 1 minute to cover the complete circle. Find this. First let's try understanding it. Okay, I'll explain it. So first you draw a circle. Okay, almost a circle, yes. Almost a circle. Now let's say the radius is, how much is the center? The radius is given as 10 centimeter. With a constant speed. Speed is constant, we don't know how much it is. But here it takes 1 minute to complete the complete circle. That means, I'll draw it again. I'll draw that again. Circle. Okay, almost circle, don't worry. Center and the radius is 10 centimeter. So here let's say the ant is starting from any point. I'll take this point. Which point this? The ant is starting here. So it completes a full circle. You can take a full circle in anti-clockwise or clockwise. Doesn't matter. If I take in this way. Starting from A, let's say A, it is also ending at A. Start and end. End or start, both of them are at A. So the initial point is A, the final point is A. Now, in this case, we have to find the distance covered. So everyone, I think we have done that, a similar question, right? So what will the distance covered be? Let's go into that here. We are completing a complete circle, full circle, so the distance will be equal to how much? Circumference, the complete boundary here, complete length of the circle, circumference, which is 2 pi r. What is pi, everyone? What is pi? Pi will mean, whenever you get pi, you have to understand its value. You have to remember its value. What is its value? 22 by 7, that's it. Into radius. What is the radius here? Radius is given as 10 centimeter. So the unit is in centimeter. The answer will also be in centimeter. 22 into 2, 44. 44 into 10, 440 by 7 centimeter. How did I do the calculation? You multiply the numerators. I'll show it to you. 2 into 22. How much? 44. Then 44 into 10. How much? You add a 0. 440 by 7 centimeter. That is what? That is distance. Clear? Then we got distance. Very simple. The first part is done. The second is find out the average speed. The distance here, one circle, the total distance also is 440 by 7. What is the time taken? 1 minute. So here total distance is equal to circumference of one circle, which is 440 by 7 centimeter. The time, total time, what is total time? Total time is 1 minute. Now you can take in terms of minute or you can take in terms of second. So what do we take it as? We'll take in terms of, let's say, seconds. Or we'll keep it in minute. Minute, it's easier for us, right? Let's leave it in terms of minutes, so 1 minute. And see what happens. So here the average speed is going to be what? Is going to be total distance by total time. Formula. What is total distance here? What did we get the total distance as? 440 by 7 centimeter. What about total time? 1 minute. So 440 by 7 upon 1. Anything divided by 1 is that same value. So 440 by 7 centimeter per minute. It is also a unit of speed. Now you can convert that into meter per second. You can convert that into kilometer per hour. Not required. We'll just leave it as centimeter per minute. Okay. So you got this. 1 and 2 you got. Now you're going to displacement part. Look at this. We need displacement. The initial point and final point are the same. Initial and final positions are same. So it's like the body did not even move at all. So when they are the same, when the initial and the final positions are same, that means displacement will be equal to 0. That means displacement is equal to 0. And if displacement is 0, we got the answer. Third one, displacement is what? 0. That is done. Then we'll go into the average velocity part. What about the average velocity? Average velocity is equal to total displacement by total time. Right here, but the displacement is 0. And forget about time. Displacement is 0. Then what will the average velocity be? 0 by anything is 0. By the way, total displacement is 0. Total time, as we know, is 1 minute. It will be 0. 0 by 1 is 0. That is the reason. A simple question, right? Very simple. Similar question, we found out distance and displacement previously. Now we just went into speed and velocity. That's it, nothing else. We just used the formula. You got the distance. For average speed, total distance by total time. Then you got displacement. Then again average velocity. This is like a revision of that question that we have already solved. Clear? Okay, that's good. That's good. That's good. Now I'll go into something called as uniform motion. Now we learned about uniform speed. Uniform speed, speed is constant. And what does uniform mean? Uniform will mean constant. It is like a constant motion. Now I'll ask you something. Let's say an object is moving towards right with 20 meter per second. An object is moving towards down 20 meter per second. Can we say their motions are the same? Can we say their motions are the same? One is going towards right. One is falling down. Are their motions same? No, they are not. Why? Because direction is different. So when do you say the two motions are same? When their speeds are equal and when their directions are also equal. Speed and direction. Yes or no? So that, keeping that in mind, so to define constant motion or uniform motion, that is the exact word, we say that body covers equal distances in equal intervals of time, constant speed, along a single direction. Direction is constant. And whenever you bring direction, what does that become? Velocity. That's why we say the body will be traveling with constant velocity. So here what is the important point? direction should be constant. So whenever speed is constant and direction is constant, both of them, or else in simple terms, velocity should be constant, then we say that it is uniform motion. Look at the definition. When a body covers equal distances in equal intervals of time, forget the brackets, along a single direction, the object is said to be in uniform motion. As simple as that. And the body will be traveling with a constant velocity. Same example, 4 p.m. to 5 p.m. time is 1 hour, distance is 30 kilometers or displacement is 30 kilometers. 5 p.m. to 6 p.m. time is 1 hour, displacement is 30 kilometers. So here velocity is 30 km per hour. Here also velocity is 30 km per hour. Velocity is constant. So this is also an example of uniform motion. Simple enough. Okay? Okay. So let's go into a simple question then, very simple one. An object travels from a point A to a point B in 1 minute. And again returns from point B to the point A along the same path in 1 minute. Is it an example of uniform motion? Yes or no? You tell me, I'll give you 1 minute of time, everyone. You tell me, I'll give you 1 minute of time, so please tell that. Is it an example of uniform motion? Think about that carefully. In fact, try drawing it, okay? Draw point A, point B, then draw the two cases. When you draw it, you will understand easily. Is it an example of uniform motion or not? Everyone, 5 seconds more. And the time is up. And by the way, the answer is no. Now I'll explain. Here let's say this point A, point B. So first we are going from A to B and then we are going from B to A. Forget about speed, forget about distance, forget about time. Look at the direction only. Here it is towards right and then towards left. Direction is changing. Or direction changes, and when direction changes, it implies velocity is not constant or it is a non-uniform motion. That is, it is not uniform motion and hence the answer is no. That's it, simple, straightforward. Clear? The answer is what? The answer is no. Okay? So we'll go into a few differences between speed and velocity. The formula, first of all, speed is distance by time. Velocity is displacement by time. Then speed has no direction, yes or no? Because ultimately distance has no direction, so speed also has no direction. Whereas velocity has direction. And what is the direction of velocity? From initial position to the final position. And speed is a scalar quantity, velocity is a vector quantity. Why? Because speed has no direction, scalar, velocity has direction, vector. Speed is always positive, whereas velocity can be positive and negative. Why? Because velocity has direction, it can be positive and negative. Speed has no direction, that's why always positive. The last point is interesting. Average speed of a moving body. Now here not a body, it is mentioned as a moving body. If a body is moving, it is covering some distance. A body is moving, it will travel some distance. So distance is not zero. If distance is not zero, speed is not zero, or average speed is not zero. So average speed of a moving body cannot be zero. Circle example. But average velocity of a moving body can be zero. When is an average velocity of a moving body zero? That is, if this is a start point and the path is in such a way that the object again comes back to the same point. The start and end are the same points, the same positions. Then what happens? Displacement is 0 and average velocity will be 0. So average velocity of a moving body can be 0. That is the interesting point. Clear? Yes? Okay. So there is one question. This is an interesting question, but we'll do that in the next class. The next class is all about practice. We'll solve it then. Okay, everyone? So in today's class, we learned about velocity. Remember, velocity is a vector quantity. It has direction. You have to be very careful about that. We learned about average velocity. We learned about uniform motion. Okay? As always, practice is the most important one. So please do practice. And thank you everyone. Thank you for the wonderful class.